Today, we're going to be taking notes on acceleration graphs. You've probably already taken notes on speed graphs. This one is going to look very, very similar, but the information and the way it's interpreted are very different. Because of that, we're going to do some special markings so that you can tell them apart easily. I'm starting with the same sheet of paper that I had last time with the same points. I'm going to be using 4 colors for this and my pen for taking notes. I'm going to begin my work by making it very clear that this is a different set of notes. So across the page in my marker, I'm going to make a wavy line. So it's very obvious this is a different page. I'm going to come down to the bottom and I'm also going to put a wavy line all along the edge of my notes. This is an acceleration graph, and I'm going to write that in all capital letters. The reason it's called an acceleration graph is because if you had the formula, you could calculate the acceleration. We don't have to worry about that in 8th grade. So in parentheses, I'm going to write can calculate acceleration. Remember that acceleration is a change in speed or direction. It's very important that you remember it's all about change when we talk acceleration. Next, in all caps, I'm going to write speed graph because that's what goes on the y-axis, speed graph. That is super, super, super important. So I'm going to give it some arrows to make it stand out a little more and look a little bit more obvious. I'll even put a little star by it. Star over here. I will go ahead and label my y-axis as speed. Once again, super, super important. So I'm going to put some arrows and some stars. Just make it look obnoxious. So it says speed. My x-axis, once again, should read time. I've plotted the same points as last time. You see all of these points here, they are all plotted for you so that you don't have to do that. But you see we've got our graph here. One of the major differences between the last graph and this one is we cannot determine our location. Cannot determine location. I have no idea if the object we're tracking is going toward home, is going away from home, is going to the mall, is going to get coffee. I don't know. There's no way to tell what's going on with it other than its speed and its change and the change of its speed over time. The very first section of the graph will be marked. You're going to go from 0, 0 up here to a speed of 9. So there's our first section. I don't actually have to do any calculating to know what speed I was going. Before, on the distance graph, we had to take the data from this section and this section, plug it into our formula to find the speed. That is no longer necessary. If I want to know the speed at a time of 4 seconds, I just look it up. Speed is 6. Then we have something going on right here. On our previous graph, that meant that it was stopped. Well, that's not really what's going on here. If you look at 6 seconds, the speed is 9. At 7 seconds, the speed is 9. It isn't being still. This section, we had a speed of 3. Here we have a speed of 6. So this is increasing speed. Increasing speed. And in parentheses down here, I'm going to put a positive, a plus sign, acceleration. This is positive acceleration. Your English teacher, if something is going faster, will say it's accelerating. Your English teacher will say it's decelerating if it's going slower. We're not going to do that in science. We're going to call it positive acceleration and negative acceleration. This section right here is constant speed. Once again, we have a speed of 11 right here and a speed of 13 here. So the speed has increased. And I'm going to write increasing. Once again, that is positive acceleration. We won't note it again simply because there's not room. Now we're going to mark this section. This is a diagonal line again. We had a speed of 13. Now we have a speed of 10. Now we have a speed of 7. Our speed is decreasing. So we'll write decreasing speed. The very fancy way to word that in parentheses underneath will be negative acceleration. Here we have a speed of 4, and then at 19 seconds we have a speed of 4, and we have a speed of 4. So this area right here has returned to being a constant speed. Remember, anytime you see a constant speed, that means something is experiencing balanced forces. Here, once again, we are decreasing. And lastly, right here, our speed, if you come all the way over here, the speed is 0. We don't know where it's at. We have no idea where this thing came to a stop. But here we're going to write stopped. And I'm going to give us a color-coded key because I think it's pretty important. We are going to have increasing speed. So in color, I'm going to write increasing speed in my red marker. Then I'm going to come up here and I'm going to mark my increasing speed. I had increasing speed for this section and increasing for this section. I'm going to come down here and write decreasing speed in my next color. And I'm going to mark where I was decreasing. This is going to be where my lines are pointing downward. Decreasing speed. I'm also going to mark constant speed. And I have 2 locations up here where my object was maintaining a constant speed, and I'll mark those. The last section that I'm going to mark is this section right here where we are stopped. I will mark it and then come down here and put it in my key. So purple for me is stopped. This is everything you need to know about interpreting an acceleration graph. Acceleration graph or speed graph, because speed is what's written on the y-axis. Be careful and watch closely what's on your y-axis. That's going to be the thing that makes or breaks you when interpreting those graphs. Did you carefully watch what's on that y-axis? Thank you.